All right, assalamu alaikum. So we're back on to part two, and we'll be finishing up with part two. But we're starting with some practices. So in the diagram below, line segment RS is perpendicular to bisector as a perpendicular bisector of line segment PQ. So as the line RS, if I didn't say that correctly, is perpendicular bisector to line segment PQ. So the information is asking us to find the length of PR. So let's find out what information we have to begin with before we can start with this. We know that this line is a perpendicular bisector of this line segment. So what that means is two things, that this is 90 degrees here. These are going to be equal to each other. But also we know from our theorem that we just did that this is going to equal this. So how can we set that up? We know that this is going to equal to this. So think about what you're saying, and you have your equation right there. We're saying that 6x is going to equal to 8x minus 9. And I have a feeling this is not going to be a whole number. So let's work this out. The easiest thing to do is bring the variables to one side and bring the constants to the other side. So let's add the 9 to both sides, the additional property of equality, you end up with 6x plus 9 is equal to 8x. Now let's bring the 6x to the other side. So we subtract 6x from here, and it cancels out. 6x from here, we're left with 2x equals 9. And I was correct that we're not going to end up with a whole number. To get x by itself, we're going to divide by 2. These cancel out. We're left with x is equal to 4.5. So 4.5. Now, is this answering our question? This is telling us to find the value of PR. So PR is from here to here. Let's plug in the information. We know that x is equal to 4.5. So let's plug it into 8x minus 9. So it'll be 8 times 4.5 minus 9. 8 times 4.5 is 32, 36. Minus 9 is going to give us 25. No, sorry, 27. 27. Right, well, let's make sure this is correct. We're going to plug it into here. Remember, this is equal to that. So if I have 6x and I plug in what I have for x, 6.45, then I end up with 24, 25, 26, 27, 27. Correct. So it does work out. We're going to have 27 here and 27 here. And that is how you put this theorem into practice. Let's do some more practice. In the diagram below, let me enlarge this. Line segment JM is perpendicular bisector of line. Sorry, line JM is a perpendicular bisector of line segment HK. So let's use the information we have. First, let's find out what's equal in this. So in this case, we know that right away they gave us this area. These two are equal. We know that this because this is a perpendicular bisector of this line segment, that this line is going to be equal to this portion. And we also know from the theorem that this line segment is going to equal to this line segment. So we know that three different lines are equal to each other, or we say congruent to each other. They're asking if line L, let me enlarge this, line L is on line segment JM. So remember the theorem we just did, the converse theorem of a bisector, says that if we have a perpendicular bisector, which we do here, and we have two things it's telling us is, perpendicular and is bisecting. Both sides are equal, and they told us that right here is a perpendicular bisector. The second thing they told us is if this line is equal to this line, then what it means is if I were to increase this line right here, it will definitely hit that point right there. So L is going to be on line segment JM, and that's from the theorem we just learned today. So let's talk about concurrency. So here's where we get back to our projects. All right, when three or more line rays or segments intersect in the same point, they are called concurrent lines. The point of intersections for these is called concurrency. Remember that three perpendicular bisectors of a triangle are concurrent, and the point of concurrency has a special property. I hope you remember what the three perpendicular bisectors where they intersect is called. But let's go over this first. So what this is saying is if I took this triangle right here and I'm focusing right here on the triangle, let me point to this. So I'm focusing only on the triangle right now. If I were to take a 90-degree line from the center and put a line upwards here, so in this case it's blue, so let me make this blue. So I did that here. And I took 90 degrees here and I made a line. And then I took 90 degrees here and I made a line also. They're going to meet up right over here. So what's special about this point? The special thing about this point is that if I took this point and I went to all the three vertices, right? 1, 2, and 3 here, um, they would all be of equal length. So this will be equal to this, and this will be equal to that. So this is really important about this. We have a name. Do you guys remember the name from the project? It's a circumcenter. So what this is saying is when you did the project, you were supposed to be using acute scalene triangle so that the points of concurrency or the circumcenter was going to be in the center. Now, had you used, I know one group used a right triangle, one of the girls' groups, what happened with their point of concurrency or their circumcenter, it should have been right over here. And then for another group, there was a group of guys that used an obtuse triangle, even though the construction specifically said use an acute scalene triangle. But when you start making 90 degrees from all of these right here, 90 degrees, 90 degrees, and then 90 degrees, the point where they all meet up, the concurrent or the circumcenter, is right there for me. So that is what the circumcenter is. And I know a few light bulbs might be going off in your head because you did this project and you researched it yourself, and some of you were still a little confused. But that's exactly what the circumcenter is. If I took a triangle, any triangle, let me just make a triangle right now. If I took a triangle and I took 3 points from the center, so let's say this is a center, and I'm not sure exactly if this is center, but let's just say it's a center, and let me use a different color marker. Let me use blue this time. So this is a center, and this is a center, and this is a center. The point where they meet up right here is a circumcenter. So technically, if I took a green marker and I put this here, here, and here, then they would all the green markers would be the same, and this would be called the circumcenter, which is what we talked about. Let me actually do this for real now. Let me use a protractor, and then we have a nifty protractor here. So what we're going to do is first let me use a ruler. I'm going to find out how long exactly this is. And the good thing about starboard is if I line up correctly, it's gonna, there we go, it's gonna equal out for me. So I'll use a ruler. Let's expand this. There we go. That's beautifully done. Exactly 24. So we have exactly 24. So at the 12 centimeter line, we're gonna mark it right here. So we can get rid of this ruler now. And now let's bring this nifty protractor in. We're gonna line up the protractor so that this point is going to be right there. And the protractor is really nice that it does that automatically for me on starboard. We're going to make sure that the lines are equal too. It's telling me we're off. Okay, let's try to get this even. And it should have lined up with this too. There we go. So 90 degrees is going to be right around here. So what I'm going to do is I'm going to take this, I'm going to make a line from here to here. And that I know is exactly 90 degrees. Now, if I did that from over here and from over here also, they're all going to meet at one point, and it's a little off, but it should be exactly at that point right there. And that would be the circumcenter of the triangle. And in this case, because of the acute scalene triangle, I know I can take a circle and let me see. There we go. So it's a little off because the whole triangle should be in there, or the vertices, yeah, the vertices, if this was perfectly accurate, this part of the triangle would hit each vertice. So my triangle is a little off, but that's because I only use a protractor on one side instead of all three sides, just because the video is going to be ending. So inshallah, I hope you enjoyed this, and we'll be doing a little project in class on this, and perhaps you'll be doing the project with the folding the paper before you even watch this video. But so if you need to watch this video again, you're always allowed, just rewind it and watch it again. We'll be doing a quick bell work on this tomorrow. All right, Jazakallah khair. Enjoy the rest of your day.